Hi to everyone, my name is Filippo Martinoni, and in this tutorial I will go through the structure of Pass Helper Provider module. Please read the code before, there are a lot of comments so that you can follow me better. So let's start by the dependency of the module. We have all this requirement. I had to put use combined word model. So as I said in the previous tutorial, normal always requires mean okay the representation of this module has to be updated before that we can use it, and uses means not necessarily. I mean, it can be updated or not. If I put here require, it doesn't work, the code, it doesn't compile. Or it compile, but when you start the simulation it crash. I have no idea why, but however it work. So here we define the module. The module is this class, and I show you very fast the representation. So the representation, of course, we can find it under representation, modeling, since we are in modeling, and we have the pass helper class. So this contains an enumeration to tell which kind of pass or shot are we going to use. If we found a pass point, the pass coordinate, the distance of the pass that will be need in order to calculate the strength of the kick, the ID of the receiver pass, this means the number of the robot that will receive the pass, and of course the enumeration. So this data will then also be sent to the other robots. Now I would go, so this is the implementation, or maybe let's tell before the attributes. So we have the parameters that I already showed you before, always from the class pass helper provided parameters. We have the pass zone. The pass zone are actually this zone here. I explain in the introduction why I divide the field in this way. So just to show you them once more, on pass helper provider parameters.h we find so all this data. For example, we have the robot radius that we want to use to calculate the shadow. We have the minimal distance that we can reach with the front kick, the maximal distance, the same for the lateral kick. This parameter, so you have all the comment here. Before a real match, so a new match on a new carpet, you should control all these parameters and then make some tests in order to find out which one are the best. I don't think it is possible to define a parameter and then keep them in any match. So because a lot will depends on the how much friction there will be between the ball and the carpet. So let's go back. We have, as I say, the parameter, the zone that are also defined here. Under the, so we have the pass helper provided parameter and another class of parameter that contain all this four area. Then we have a points field points, and we have a double pointer. Double pointer, what it means? It means that this is what we initialize. I show you in the previous video how the points field work, and this offered us to access the whole field with this index. This means that, for example, if we take the real field, this point here will correspond to 0, 0. This point here will correspond to this point 1, 0. So as you can see here, we have to increase this number, this stays 0, and so on. Then we have the possible index pointers, so that are a vector containing all the possible index where to make a pass. This means, in other words, if I this means these points, okay, just the index. Selected index point means the points that we can select after that we calculate the shadow. This means this red point. Calculations, so this flag we need in order to define if we want to calculate, so where to pass the ball or not. I already show and explained this drawing in a previous video. Then on the representation, of course, I could avoid that, but I did it because I like. So I defined with the same name of the representation all the parameter. At the end, I will override the representation with this data. Then we have driving element. So I will explain very fast in another video how they work. So let's say that they are just classes that contain all the options, such that if we want to change just one parameter, all the drawing that we did will change at the same time, and we don't have to change every single drawing. And then we have a bunch of functions. I will go through every function, I think it's easier. And also all the drive functions that are for us actually to get all these options here. So let's go through the functions. So we have first the constructor that will initialize our pointer, and also the possible point index and the selected points index. So these two vectors are actually an array of vector. This is why, because let's say that let's make an example. So let's say that we want to choose a point here. If I would put all the red point in the same vector, then I would anymore be able, or I should make new calculation in order to find that actually this point should correspond to the robot number 5. But since we distinguish from the beginning which point belongs to which robot, we can know directly what is the ID, so what is the number of the robot that is going to get the ball. Here on the update function, so first we define this modify macro. We use it for the instance of the legend and of the drawing in order to set all the stuff true or false. Then so what we did here, we tell, okay, since in pass helper parameters we have the function continuous calculation. This continuous calculation means that we don't use this technique, but we make that the robot will continuously, so the model will continuously work and continuously calculate where the ball should throw, so the pass point. But in a real match we should set it to false, always to false. So this is just if we want to make something new and we would like so to see according to how do I change the ball, how will change the different stuff. In this case we need the continuous calculation. Why this? Because let's say that we make it, we put like as a false, we compile the code, and now we have the problem that this calculation will work just if the robot, so the passing robot, is in the interval that I show you. So let me take me away these two. So now, as you can see, for example, there is no drawing, but as soon as the robot will, so as soon as the robot, in this case the passing robot that is the number 1, will find itself in between, so between the ball and some treasure, we are going to get the drawing. So I come here with the ball, and we don't see any shadow. This is very strange. I'm wondering why. Okay, so sorry, I remember now why it's like that. This because the flag, in this case, this flag, so this calculation is done just if the player is active. These signs in the state machine of the robot, there is written, I will show in another video how this machine works, but however the robot should be active. So if now I call the game ready and the game play, as soon as the ball will be near the robot, you see that the drawing will happen. Now let's say that I move the ball here. As you can see that the drawing doesn't change because the robot is not able at the moment to make new calculation, but as soon as it will come near the ball, the drawing will change, signs, so new points will be calculated. So every time that the distance between the robot and the ball is either here outside or in this range here, the drawing, so all the calculation will stay fixed, and since we don't set all the value every time to 0, or we don't initialize every time the value, they will stay the same. So this is the main reason. Now in order to continue the tutorial, let's leave this value true. Then what do we have more? So this was in order to avoid too much calculation. Now as I say here, we get the, so first of all, if the parameter so if we write here this as a true, the calculation, as I say, will always be true. But if we put that to false, according to a personal data of the robot with the flag need to calculate, we will say if the robot need calculation or not. Just for maybe to completeness, so on the pass player, we go on the option pass, and on the option pass, we have the transition. So as we start with the pass player, we as common transition all make an update, so of all the data, and we say, okay, if the distance of the ball is smaller than stop pass calculation, so if the distance to the ball is smaller than distance here, then go to pass decision. In pass decision, so I'm sorry, I say something wrong. If this distance here, if the distance between pass player and the ball is bigger than this distance, then you have to go to the state pass decision. In pass decision, according to if my distance to ball is smaller than this distance, what does it mean? This means that if we are in this range now, so stop the calculation, we say we want to stop the calculation. This means that we go, so the calculation stops. Now if we found a pass point, we are going to, according to the kind of pass that we want to perform, so play a sound, so tell for example passing forward pass to robot 1 or something like that. Or if we don't find any point, we're going just to shot to the opponent goal. This update function that is called at every iteration, we use the flag the function, we call the function need to calculate, and this need to calculate is going to set this need to calculate pass true or false. That's actually what we found here. So why I implement the stuff like that? So I found intelligent that the module don't have to decide alone where it has to perform the calculation or not. So the module just can work or not, but from outside we can decide if it has to make the calculation or not, and not the module itself. This also to make it more reusable. So let's say that I don't know, maybe you are listening to me, you want to implement something that will change from robot to robot. So since the module that run, so this module that run in every robot is independent from the same module on the other robot, you can make that one maybe calculate more and the other one less. But if you would implement this condition on the module itself, then it will make the same stuff for every robot. Just to finish on the pass player, now is on the pass skill. So if as I say, we found a pass point, then we are also going to communicate that to the other robot, so that the robot that get the message that you are the chosen target of the pass, it will directly stop whatever he's doing and walk to the pass point. This is just so we go in the state, for example, pass front, and here we just say, okay, kick, walk and kick to the pass coordinate. Walk and kick means walk to the ball and kick the ball to the location, so to the vector 2 that we give you. Now to come back to the module, then as I say, here we calculate if we need this calculation or not, and here if the calculation are needed, we first find the possible point, then we calculate the shadow, we evaluate the possible point, and then we decide finally the pass point, and at the end we update the representation. So just to repeat it once more, if we run the code, so what we do, first we find the grid of point, then we find the possible target, we calculate the shadow, we select the point that are possible for the pass, so the red one, and then according to the zone where we find ourselves, we select either the forward, the backward, or the lateral pass. Then we have the function draw, that it's just to make all the drawing. So as you can see, we have all this if, and this if are actually what we have if, so that we can select or not some drawing. So as I explained you have at the beginning, if you want to see then a drawing, put the flag on true, else it will not work. So now I will go, so as we have the point field that is generated in the constructor, so it's actually generated here, we have to find the possible points, and here what we do, we have a parameter that is the minus parameter square half dimension, that is actually the dimension in indices that we want to select. So if for example if for example robot 4 find itself, let's say here, it will calculate how much point in this direction, in this, and then this should I count, and it store all the index in the vector possible index. Here we do this operation, so we select first which index are valid and not, and then we save, we push all these index in this vector. Then we have the drawing function, calculate the shadow. So what we do for all our team and for all the obstacle, we calculate the shadow. So what we do, we calculate first the parameter of this line, and then according to in which quadrant this line finds herself, we say, for example, in this case, a point that is between, so is bigger than this line but is smaller than this line, will be set to false. If and only if this distance, so we also first calculate this distance, and we say, okay, if the distance between the point and the ball is smaller than so if the distance between here and here is smaller, so between here and the point is smaller than the distance between here and here, or better say between here, the center of the crisis, minus the circle, minus the radius, then you don't have to count this point because are in between you and the pass player, so there is no obstacle in between. And then we select according to the two straight line. If you have a look at the documentation, there is an explanation that maybe can help you to understand better. So it will also explain why actually, for example, these 2 points are seen as white, even if they are not between the possible point. But this is also because here we are not consider just the possible point, that would be just this one, but we are just looking which point are not valid for the pass. So here we do all this operation. We have to distinguish between the slope, if it is positive or negative, of the different straight line. Then we have the draw function. Evaluate possible point mean since so with the draw shadow we put on the field, so we know every of this point if it's valid or not, and with this evaluate function we just since we have the index of all these points in the square, we just look if with the same, since the index is the same, we are going to get a point that is valid or not, and we store all the valid point in the selected point index vector. Then so all the draw function I don't have to explain you, I mean you can have a look at it, and if you look also on the general tutorial you will understand quite fast how they work. Then we have the side pass point, that here actually according to the zone where we are, we decide if perform a forward, a backward, or a lateral point. So normally we always have this flag, found pass point, that if it's set to true, it means okay, I found a pass point, so you don't need to calculate more. Also because we have some preference, as I explained in the introduction. For example, if we find ourselves here, we are going to perform just a forward pass, so the other lateral and backward pass are not considered. But if we find ourselves here, we are going to perform either a forward or a lateral pass. But I set that I prefer to do a forward pass than a lateral one. So first we use the function find a forward pass point. If this is not the case, then we're going to consider, so to search for a lateral pass point. Then we have the function, of course, decide pass point forward. As I already explained, what I do here, I just see, okay, I want, if I'm here with the ball, I want to search a point here outside. Then if I have more point that could be valid, I choose the more distance, and so on. So this is what I did here. The same is for the backward pass, and something very similar is this side pass point lateral. This is actually all what you have to know. However, look at the code, because I tried to comment it as more as I could, so that I hope you will not get stuck to understand the code. However, I can tell you that I'm quite confident in that, because I tested it quite a lot, so hopefully, or I'm quite sure about it, you should not have any problem on that. So my idea was to implement this the framework, so these modules, so that you have all these points, all these criticized points, where you can either make a pass or whatever you want, but what you will have to do is to improve the pass skills. So not to work on the module, so just get the output of the module, this representation, and then work with this data. Thank you for your attention.